Hi, in this video, I'm going to show you how to do an analysis of variance in statcrunch using a full data set to begin with. And the data set that I'm using as an example is this data set on movie budgets and box office earnings. And I'm interested in whether the budgets of movies vary by month. And so to first explore the data, I'm going to actually make a box plot of the budgets grouped by the month in which the movie was released. If I click compute, then I get my box plot. And what I see is that it looks like the movies that are released in the summer, so like May, June, July, look like they sometimes have a little bit bigger budget. And also the movies that are released around the holidays in November and December look like they have a bigger budget. So maybe the other ones are smaller. So we could use an analysis of variance to check whether the mean movie budget is different from month to month. Now, before we went too far with this, we would probably want to do some checking of the conditions. For example, it looks like a lot of these budgets are skewed to the right, so we might want to do some double checking on the nearly normal condition and the constant variance condition. But here I'm just trying to show you how to carry out the analysis of variance test. Not saying that is necessarily a good idea for this data set, but let's carry out the test as an example. So I go to Stat, Anova, one way, and then I want to pick values in a single column. So we have data set up the way that we have it with one column for month and one column for budget. We want to do values in a single column. Response is the thing that you want to compute the mean of. So for us, that's budget. And then the factors are the categorical variable that gives the groups. And so for us, that's month. So we want to know if the budget is different for different months. And then we'll leave everything else as is for now and just click compute. And our results table gives us the averages for each month with standard deviations and sample sizes and errors. And we can see that, as we saw in our box plot, they do seem to vary by month. And if we look down at the bottom at our Anova table, it does look like there's a significant p-value. And we can look at the rest of the Anova table if we want to. So from this, we would conclude that at least one of the months is different from the others. But now that we have a significant analysis of variance result, we probably want to do the pairwise comparisons, a Tukey test. So if we go to options and edit, we can go back down into the options and ask to compute Tukey's HSD test using a 95% confidence level. Click compute. And now we have more results to scroll down, and the Tukey HSD results are also included here. So there are a lot of different results here because we have so many different pairs. So differences between January and each of the other months. Here are our p-values. And then February versus each of these different months. We have a ton of p-values here. So it's a good thing that we did that Tukey adjustment because we have done a lot of multiple comparisons when we have 12 different groups. But if we wanted to know for any particular pair of months whether this test is telling us they're significantly different, we can look at the p-value column of these results, and that should answer the hypothesis test, or we could also compute confidence intervals using the lower and upper bounds given, and the table also, of course, gives us the actual observed differences like March subtracted from April, etc.